Welcome back to Maths Free Manual. On this one, we're gonna be starting geometric progression. So I've been doing a topic, sequence and series. So we are done with arithmetic progression, and now I'm starting geometric progression. So under geometric progression, we have the nth term of a GP, and also the sum to infinity, and also the sum of terms also. So we start with the introduction to GP. So geometric progression is a form of sequence that has a common ratio after any term and the preceding term. For example, we have this series, we have this sequence 2, 4, 8, and so on. So this is an example of geometric progression. Let's check to know if a sequence is a geometric progression. We'll divide it because this is our T1, this is our T2, and this is our T3. On AP, to get the common ratio, to get the common difference, we do the T2 minus T1. But in GP, to get the common difference, to get the common ratio rather, we do the T2 divided by the T1. The same thing, we do the T3 divided by T2. And that's how we get the common ratio in GP. So doing that now, to check if it's a GP, the T2 is 4 divided by 2. It's the same thing as 8 divided by 4. So 4 divided by 2 is 2, and 8 divided by 4 is 2. So you can see that the common ratio is 2. And once you see that it's 2, you know that it's a geometric progression. So I'll be starting nth term of a GP. So the nth term of a GP. Now in GP, we denote the first term as our A. Our A is the first term. Then our common ratio is denoted with the sign arrow. So I'll be deriving the formula to solve nth term of a GP. Now in GP, our first term is A, which is T1 is A, and our T2, which is the second term, is A arrow. T3, which is the third term, is A arrow square. T4, which is the fourth term, is A arrow raised to the power of 3. T5 is equal to A arrow raised to the power of 4. So these are all the terms in our GP are arranged. So to get the nth term, take note. Anytime we are having T2, because this 2 here is the number of terms, T2, the power is being subtracted by 1. If we have T3 here, we have it to be A arrow raised to the power of 2. That means the number here is n. Will be subtracted, 1 will be subtracted from it to get the formula. So the same thing applies. If you have T of 100, we have it to be A arrow raised to the power of 99. So to get the formula, it will be T of n will be equal to A arrow raised to the power of n minus 1. So when you subtract 1 from the number of terms, we get the formula. So this is the formula of solving nth term of a GP. So I'll be starting with some few examples. Action. Now I've gotten the formula to solve sum of GP. So you are given the first question. Find the 7th term of the geometric progression 4, 12, 36, and so on. So you are given the first term, second term, and third term, and we are asked to find the 7th term. So to find the 7th term, we get our first term to be 4. Then we find our arrow, which is the common ratio. So our arrow now is the T2 divided by the T1, or the T3 divided by the T2. You have it to be 12 divided by 4, which should be 3. So the common ratio is 3. Now I go to the first term and the common ratio. And now you have to find the 7th term. So our n will be 7. Now let's solve it with the formula. T of n is equal to A arrow raised to the power of n minus 1. So T of 7, which is the 7th term we are looking for, will be equal to A is 4 times arrow is 3 raised to the power of 7 minus 1. So 4 times 3 raised to the power of 7 minus 1 is 6. So 4 will multiply 3 raised to the power of 6 is 729. So 4 times 729 is 290 2916. So the seventh term of this geometric progression is 2916. Let me give the second example. So now you are giving the second example. This is the second example. The first term of a geometric progression is 6 and its common ratio is 3, and we are asked to find the system. So doing that, to write it out, our first term is 6 and our common ratio is 3. So they ask us to find the system. The number of terms, which is n, will be equal to 6. So solving this now, use the nth term. T of n is equal to a r raised to the power of n minus 1. So T of 6 will be equal to a is 6 times r is 3 raised to the power of 6 minus 1. So 6 times 6 minus 1 is 5. So 3 will raised to the power of 5. So you have it to be T of 6 will be equal to 6 times 3 raised to the power of 5 is the same thing as 3 times 3 times 3 times 3 times 3 in 5 places. So 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Then 81 times 3 is 243. So 3 raised to the power of 5 is 243. So we have it to be 243. So now 6 times 243. 243 times 6. 6 times 3 is 18. We write 8, carry 1. Then 6 times 4 is 24. 24 plus 1 is 5, we carry 2. Then 6 times 2 is 12. Plus 2 is 14. So I have it to be 1458. So the system of the geometric progression is 1458. Now let's do the third example. Now we are given a third example. If y plus 2, y plus 6, and y plus 14 are consecutive terms of a GP, find the value of y, hence the GP, and the 42nd term of the GP, leaving your answer in index form. So now let's solve it. To solve it, we are given the first term as y plus 2, the second term as y plus 6, and the third term as y plus 14. So using the idea from a GP, don't forget that our T2 all over T1 is the same thing as our T3 all over T2. This to get the common ratio. So now our T2 now is y plus 6. So y plus 6 all over the first term, which is y plus 2, will be equal to y plus 14 all over y plus 6. So I'm going to cross multiply. So cross multiply, have it to be y plus 6 into y plus 6 will be equal to y plus 14 into y plus 2. So doing that, y times y is y square, then y times 6 is 6y. 6 times y is 6y, then 6 times 6 is 36. The same thing we do here, y times y is y square, plus y times 2 is 2y, plus 14 times y is 14y, plus 14 times 2 is 28. So now solve it. 6y plus 6y is 12y, having to be y square plus 12y plus 36 is equal to y square plus 14 plus 2 is 16y plus 28. So from here I'm going to collect like terms. So I'll collect like terms. Have it to be y square, or bring this y square over here, minus y square plus 12y. Now bring this 16 here, minus 16y will be equal to 28. Then I'll bring 36 here, minus 36. So y square minus y square is out. 12y minus 16y is minus 4y. Then 28 minus 36 is minus 8. So from here I'm going to divide both side by minus 4. Or divide both side by minus 4. So minus 4 will cancel minus 4, minus will cancel minus, and 4 will divide it 2 times. So y will be equal to 2. Now I've gotten the value of y. So I'm going to substitute this value of y back into all these terms to get the GP, because they said find the GP. So the GP will be 2 plus 2, which is the first term, then 2 plus 6 is the second term, and the third term will be 2 plus 14. So 2 plus 2 is 4, 2 plus 6 is 8, and finally the third term is 16. So this is the GP. This is the GP. Now I've gotten the first, second, and third term. So you are done with this first part of the question. Now let's solve the second part, which is the II. So now the II, they said you should find the 42nd term. So to find it, we use the formula T of n will be equal to AR raised to the power of n minus 1. And now they are giving our n will be 42. So solve it now. T of 42 will be equal to A, which is the first term, is 4, times R, which is the common ratio. We divide it. 4 divided by 8 divided by 4 is 2. 16 divided by 8 is 2. So the common ratio is 2 raised to the power of 42 minus 1. So you have it to be 4 is the same thing as 2 raised to the power of 2 is in index form. So 2 raised to the power of 2 times 2 raised to the power of 42 minus 1 is 41. So now in the question they said leaving your answer in index form. So I'm going to solve this like an indices. So according to the law of indices, when the values are the same and you're having a multiplication sign, you are going to add the index. So finally we have it to be 2 raised to the power of 2 plus 41 is 43. So 2 raised to the power of 43 is the 42nd term of the geometric progression. So that's all for nth term of GP. My next video I'll be doing the sum of terms of a GP. So please don't forget to subscribe to this channel, like and comment this video, and stay tuned for the next one.